Chapter 4, Variables and Assignments. This chapter shouldn't be anything new, or not much new, so it should be relatively easy for you guys to understand and complete all the assignments. So, integers, we've already gone over that. It's a number type, a whole number. And first off, we'll do this participation. So, for each step, keep track of the current number of people by typing in known people in the box. So, alright. So, step 1, you're getting on a bus. The bus gets on 5 people, 3 people get on. So, it should be 8 people. Okay. Then next, 3 people get on, which we already have. 2 people get off, so now our variable is going to change to 2. We're going to complete the assignment. Okay. So, a variable represents memory used to store data. Quotient is like the box up here. So there's some memory address, and the value changes. If it's a primitive type, the value is actually in the variable. Okay. So, basic integer definition. We should initialize everything before you use it. Not bad at this point to always make everything 0. You could do int variable name equals some other assignment, but you do have to initialize it before you can access it. So, again, the variable type, the variable name, the equal sign, and some initialization. Complete participation activity, and continue going through. So to find a second integer variable, we'll average lifespan initialize to 70. Okay, so currently we have integer variable user age. Okay, and we want to have int avg lifespan, and that's supposed to start at 70. Okay, then add a statement that prints the average lifespan is 70. Don't type 70, right? You want this program, you want all programs to be flexible so they can work with anything. So in quotes for the string average lifespan is quotes plus avg lifespan as a variable. Enter age, 20, average lifespan is 70. It looks like that one works. Common error is to read a variable not been assigned. And so you can't come up here and say average lifespan semicolon and then print it. It's going to throw up an error. And complete the rest. Assignments, again this is in 4.2, should be nothing new. Assignment statement, num apples equals 8, so it starts on the right side of the expression and then we'll store the data in the variable name. Expression may be a number or a calculation. We got shorthands of plus minus, that sort of thing. So here we have 3 variables that are initialized, and then we reassign them. Okay? Now once you have initialized a variable, and you told the computer its type, you don't reinitialize it. So once we have int letter size equals 3, then letter size equals 14. I don't say int letter size again because it's already been declared. So select the correct value for x, y, and z after the following code executes. So all 3 variables are initialized. So we're going to start. So at step 1, x is 7, y is 6, z is 4. To the solution, each line of code is an assignment. Oh, the whole thing is going to roll through, right? So then x gets reassigned to 1. Next. No, we're going to check it again. So x starts at 6. Next line, y is 9. Z is 3. And then this will complete and x becomes 3. Again, x starts at 6. Y is 9. Z is 3. X is 3. Y is 8. Complete the assignment. Common error. Equals is not equals. Double equals means check equality. Single equal sign is the assignment operator. Right? And it goes right side, left side. So whatever, in this case, if you write numcats equals numdogs value, or whatever's stored there, gets stored into numcats. It goes, completes the right side, and it goes to the left side. Write in a statement that assigns 3 to hours left. Well, int hours left equals 0. So it's already been initialized. Hours left equals 3. Again, just don't, it's already been initialized, now you can use it. Identifier types. Okay, name created by programmer for a variable is called identifier. Identifier must be a sequence of letters, lowercase a through z, capital A through z, underscore $sign, or the numbers 0 through 9. It must start with a letter. Underscore and $sign considered to be letters. A good practice is to not use them in program-created identifiers. So these are all valid. C, cat, cat. Now notice that cat and cat are different because we have a lowercase and uppercase letter, and the computer takes those as different. And we do this in reserved words: int, short, double, new, import, things like that you can't use. We'll go through and say whether or not these are valid. Okay. Identifiers are case sensitive, and we do what's called lower camel case, which means num apples first letter of a variable becomes lowercase, and then every other word in that variable name is capitalized. Capitalizing all letters is for a class identifier.
When you start, can you use that so I can see it quicker?
So, Java reserved words. Ones you cannot use because they already have a specific thing in the computer. Arithmetic expressions, we know how to do these. You can add, you can multiply, you can make things negative. Go through this one, that should not be anything particularly challenging for you. We do have to be careful when you're dividing. Fractions are integer division. If there's no decimal in the division, then it says you're telling the computer do integer division, which means whatever the remainder is disappears. So there are times when this is very important, and times when that's an accident. The modulo operator, the percent sign, only gives you the remainder. So 24 mod 10 goes into 24 2 times with 4 left over, so your answer becomes 4. Okay. You need to store this somewhere or print it, but generally you're going to do an expression like that, and you're going to store the data. So for instance, out hours equals user minutes divided by 60. Out minutes equals user minutes mod 60. So, because you need, then you need to save them. So the computer will happily do the math, but if you don't tell it to save them anywhere, it will disappear. Division by 0 is an error. It's a runtime error. The computer will wait until the program attempts to run to see if that's going to stay as a 0. Go through the practice activity. Parentheses, order of operations work. But here's the precedence. Parentheses first. A negative gets the next precedence. Multiplication, division, modulo. Addition, subtraction, and then left and right. Complete these activities. Challenge activity. Write a statement that computes num1 plus num2 divided by 3. This assigns the result to the final result. Example, if num1 is 4, num2 is 5, the final result is 3. Okay, because I have 9 divided by 3. So we have num1, num2. So here, we already have final result. It has been initialized, so we can use it. Equals num1 plus num2 divided by 3. And this is integer division. So the final result gets 3, but any remainder will get lost. Floating points, doubles. I can put an integer into a double. I cannot put a double into an integer. The memory size doesn't fit, and you'll get an error. All right, go through for assigning double variables, very much like integers. Scientific notation can be used. Given a sphere radius and pi value, compute the volume of a sphere and assign to sphere volume. Use 4.0 divided by 3.0. So since at least one of these is a decimal or floating point number, a double, the whole thing will become will not be integer division. Okay, so we're going to assign to sphere volume, which has already been initialized. So sphere volume equals 4.0 divided by 3.0 times pi value times, we can say sphere radius times sphere radius times sphere radius. And then do this again for the acceleration of gravity activity. Constant variables. We've gone over constants. Remember, it means it can't be changed. So final double. So you put the keyword final in front of it, and generally we can make it all uppercase letters with underscores to go in between, because obviously camel case doesn't work. Again, this is nice because if I'm going to use the speed of sound at the sea level value of 761.2 miles per hour, if I wanted to change that anywhere else in my program, if I was to just again put in the number 761 throughout my program, and let's say it was in there 20 times and I needed to go change it, there's a good chance I'm going to miss one or make a mistake or whatever. If I make a constant, first off, it's very obvious when I'm working my program what the number means, but also it makes it very easy to change, because now if I write speed of sound 500 times in my program and I decide I want to change it and use the value at a higher altitude, I just have to come here and change it once, and I know there's not going to be any mistakes because this is a constant and it's just going to work for everything else. So I'll go through the practice and the challenge activity. Math methods, we've been working on with those already. You don't necessarily have to import math class. So they are static, so you don't make objects with a math class, you just use math methods. So there are some very powerful ones that we will use. Power, if you want. Square root you will use a lot. Absolute value, that's a good one. And then if you're doing trigonometry functions, but the big ones are going to be power, square root, absolute value, and round. Also maximum and min are useful ones as well. Type conversions. Sometimes we really want to force the program to be one thing and the other. Now, if I was doing integer division, I can store it into a double, it will automatically turn it into a double. I'm doing double operations on double variables, and I need to change them for something, one reason I need it to be an integer, I can do that. It's called a cast, and I can force the computer to switch between something. So you're going to have a problem if you try to go double to int, because one, it won't fit, but it's also going to lose precision. The computer's going to say, hey, this is 4.5, and you're going to turn it into 4. Is that actually what you want to do? So you can tell it yes or no. So do the answer. Because of implicit conversion, statements like double some variable equals 0 or 5 are allowed but discouraged, you would want to make it obvious that it's a decimal value, so start with a 0.0 or something like that. So I can cast, for instance, if I wanted to do the average kids per family, I could do my division, which is double division, and I can put in front of it, in parentheses, where I want it to change it to. Now, not all things can change back and forth, but at this level, numbers can go back and forth. Okay. So a couple ways of doing it. In this case, making the operands doubles, or to make, which will save your math. If I made the entire answer a double, it's not going to round, and so I will have lost precision beforehand. Okay. And run the challenge activity. Binary. Do the assignment and the practice ones. Characters, we don't do a whole lot with characters every so often. It's a primitive type called char, stands for character, and it gets a single quote instead of a double, and then there's a symbol in between. They there's sometimes reasons when this is useful. Instead of using a string is an object, takes up more memory space, is slower to operate, and I have to use methods. I can't use like just the equal sign to check things. So there are times when characters or chars are useful to use. Okay, if I put it in double quotes, it becomes a string. Modify the program to use char variable alert system for the exclamation symbols found in the word warning and test. So I've got a dash, system out print warning, system out print, modify the program to use a char variable. Okay. So character alert symbol equals single quote, the exclamation symbol. Okay. Then here I'm going to print warning and dash dash, but I don't want to do that. I want to modify this so that this is going to print warning. But first I'm going to print my alert symbol plus warning plus alert symbol. And again, this makes my program more flexible. If I decided I wanted to change my alert symbol, I only have to change it once in my program instead of changing it every time I print, every print command. Keep going through, finish it out. That should be pretty easy. Strings you've already worked with a lot. Strings are objects, and they store everything in the computer in a sequence, in what's called an array. Okay? And then they have memory addresses for each individual character. If you're requesting input from the user, currently we've used scanner, make an object of the scanner class, calling system in, so that it uses the keyboard. And up to now we've used next int and next double, but here we want either next or next line. Next line gets everything until I hit enter. So if there's a space because you have a first and last name, then, or in this case like a space in your first name, it will get it. If you use just next without the word line, it stops at the next white space, which is either a space character or a new line or enter. So in this case it would miss the little second part of the name. Now, even though strings are objects, you use them so often that Java has allowed you to forego having to call a constructor and use the word new. You can just use an assignment statement similar to a primitive type, but do know that strings are objects and are therefore very different. Integer overflow, this is a good problem. There's a fixed size that an integer can hold. And once you go bigger than that number, it just won't fit. And so it's going to give you a mistake. Long variables, floats, shorts, you are not required to use those on the AP exam. They're useful for real programming, but as far as the AP exam is concerned, ints and doubles are your number choices. So again, going through longs and other things, but don't worry about it too much. I'm not going to test you on this. The only time that you would have to deal with a long is that the math.round function returns a long value. You need to change it from there. Random numbers, we've worked on that already. You can use objects of the random class, and then call next int, next double, etc. Remember that the number in parentheses, it will go up to but not including that number, and it starts at 0. So in this case, it will go up to 5, 0 to 5, but if I want 1 through 6, then we need to stop at 6 and then add 1 to the final result. Not entirely true random. You have, generating more and more complex random algorithms is a very common programming challenge. Using the API, we've gone over that already, how you should be using that fairly regularly. You go to the guide, look at the class, and you can look at your methods and everything else. Go through that. I don't think I need to read that to you. Debugging, troubleshooting. Again, if you're going to run a tester class, it should test all methods, and you should always have expected values that you have calculated by hand, so you know if your program's working correctly. But you also need to work on boundary cases. So if I'm testing, once you get into sort of if statements and whatever, if I'm testing a program that should do one thing if some value is less than 5, and more if it's something different if it's greater than 5, I need to test all possibilities. So I need to test a value less than 5 and see if that works correctly. I need to test a value greater than 5, and I really should also test 5 itself and see if it falls in the correct range. Style guidelines, white space makes your program so much easier to read. So please put those in. Blank line. Related statements should go together. This is hard to read. This kind of indicates that these two things are separate, but if they're supposed to go together, then put them together. Most items are separated by one space. You don't need more than that. Subspaces are indented. Just hit tab. I don't like the bracket up there. I like to put the bracket down and then tab everything in. For me, it makes it easier to see block statements. But that's personal preference. Braces, everything inside a block statement. I use this. I like that more than I like this style, but it is whatever you want to do. And again, I do agree with this, except dropping the curly brace down. This is messy, don't do that. This is legal. You will automatically enter the first line. This is a common mistake on multiple choice questions. This is a common, we're going to try to trip you up error. It doesn't hurt to put everything inside of braces for a block statement. That way you never have to worry about what's called a dangling else, which we'll get into later. Participation activity, do that. Run through the participation activity. And then run the lab submission. Again, remember these challenge and labs are only going to be worth a test grade. Or one program grade, not a larger program grade. But again, if you can handle these, then you know you are very comfortable with the material that we've been working on. So, prompt the user to input an integer, a double, a character, and a string, storing each of the separate variables. Then output the 4. That's step 1. So, enter integer 99. So we got a scanner, we got our variables, enter an integer, save it. Next thing, system out println, it should say enter a double. Close, enter a double, curly brace. Now, double is called user double equals scanner dot next double. That's really system out println, enter a character, or enter character. No, there's no word in. So enter double, enter character. So we don't have a character, right? So we need to finish the definition. So char doesn't have a name, does it? So user char to stay with convention, and this should equal the empty character. String user string equals the empty string. So user char equals scanner dot next. And we go through. So read them, then output them on a single line followed by spaces. So print. So integer, print user double, blah blah blah. Then print them in reverse, so print user string, user character. Expand to cast the double to an integer, and then output that integer. Alright, so 377 cast to an integer is 3. So you could do the cast all at once, or you could save it in a variable, such as int cast user double equals 0. Cast user double equals int user double. System out print ln blah 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 blah. The rest the appropriate thing. And then save it runs. And complete the other assignments. Again, if you can do these are a little more advanced than what I need you to be able to do at this point, but if you can complete these, you are doing just fine. Any questions? Send me an email.